Okay, so let's continue for the last part of this paper, which is we are going to discuss for question 31. So let's go through this question together. So this table 2 shows us some of the ingredients used in two types of the products. Okay, so obviously we have the lipstick at the left and we have the chocolate at the right. So the question wants us to find what is the correct use of the same ingredient in both products. So okay, it says that in these two products we have the same ingredient. So let's go through the ingredient together. So we have the xanthan gum, oil, fragrance, and lecithin in the lipstick. Meanwhile, for the chocolate, we have the sugar, milk, cocoa butter, and the lecithin. So the same ingredient in both products is the lecithin. So we are going to find what is the correct function, correct use for lecithin. So for information, lecithin is actually a lipid. It is a phospholipid. So the function of it is to emulsify two immiscible liquids. It is a emulsifier. So in this chapter, in this question, the answer for it will be emulsify the two immiscible liquids. Okay. For A, it is thicken the product. It means that it is a thickening agent. And then for the substance that slows down the oxidation effects, we call it as antioxidant. And then give uniform and smooth texture, we call it as the stabilizer. Okay, so for the next question, we have this reaction to produce a fertilizer X. So the reaction between nitric acid, which is HNO3, with the ammonia will form the fertilizer X. So we are going to identify the percentage of the nitrogen by mass in the fertilizer X. So let's write the chemical equation for this reaction first. So the nitric acid react with the ammonia will form the ammonium nitrate. Okay, so this is the formula for the fertilizer X. So this is actually our X, our fertilizer X. But in this question, we want to find the percentage of the nitrogen, isn't it? So the formula will be percentage of the nitrogen by mass equals to the relative atomic mass of the X over the relative atomic mass of the nitrogen we have times 100%. So for the fertilizer X, which is the ammonium nitrate, so we have 2 ends, so the upper part will be 2 times 14, and then the 14 plus 4 plus 14 plus 16 times 3 equals to 48. And then we need to test 100% because it is the percentage by mass. So let's calculate for the answer. So we will get 28 over 80. So let's calculate for that. So our answer would be B, which is 35%. So when we want to solve this kind of question, so it's actually very easy. You just get the whole formula of the chemical compound that you want to test, and then the upper part you just list down what is the percentage of the element of all the substance that you want, and then lastly you times the 100%, and then you will get the answer. So let's continue with the discussion for this question. So okay, we have why is the group 17 element in the periodic table of the elements. So what is the volume of the gas Y2 needed to react completely with 5.6 grams of the iron at room condition? Okay, the information that we get is that Y is a group 17 element and it will react with the iron, which is the metal, right? Okay, so for group 17 element, it is actually the halogen, where it it might be fluorine, chlorine, bromine, or anything. So they are also a non-metal. The group 17 element is a non-metal. So for the reaction between metal and non-metal, it will result in the ionic compound. So since we have this ionic compound, so actually we know that this ion can react with the Y2 to form a substance, right? So let's say we have this iron 2 plus react with the chlorine, react with the Y, which is it has a negative one charge. So the the charge for the ion is like Fe 3 plus, which is it is a brown color substance. So they will form FeY3. So in order to balance the equation, we will put 3 for the Y2, and then we get 2 FeY3. Then since left we only have one, at the left hand side we only have one ion, and at the right hand side we have 2, so we put 2 over in front of it. Okay, so first thing we want to know, we can calculate, is the number of mole of the ion, which is equals to the mass divided by the molar mass. So for this question we will have 5.6 divided by 56, which is 0.1 mole of the ion we have. So let's compare the number of, so since we already get the number of mole for the ion, so we need to get the number of mole of the Y2, which is the group 17 element. So we have, okay, so 2 mole of the Fe is equivalent to 0.1 mole, isn't it? So 1 mole of the Fe will equals to 0.05 mole. So since we have 3 mole of the Y2, so it will be 3 times 0.05, which is 1.05 mole. So this is actually just you compare for the ratio. Is 0. Okay, I calculate it wrongly, so it is 0.05, and then we times it with 3, which is 0.15 mole. So we will get 0.15 mole for the mole of the element Y. So next, we are going to find what is the volume of the gas, right? And we know that volume of the gas, volume of Y2 equals to the number of mole of Y2 times the molar volume, which is in this question we are provided with 24 dm³ per mole. So let's calculate for it. So we will get 3.6 dm³. So our answer will be C. That's how we solve the questions step by step. Okay, for the next question. The soil in NJ Ahmad's farm is not suitable for agricultural activities since it is too near to the industry factory which emit the poisonous gases. The situation becomes worse when it is raining. What is the substance that can help NJ Ahmad to solve his problem? Okay, the first information we get is the soil in the NJ Ahmad's farm is not suitable for agricultural activities since it is too near to the factories which emit the poisonous gas, and it becomes worse when it is raining. So we can actually reasonable to predict that this poisonous gas is actually sulfur dioxide, and we know that when this sulfur dioxide react with the rain, it will produce the acid rain. So it means that this soil is actually too acidic, so it is not suitable for the plant's growth, for the growth of the crops. So in order to solve this kind of situation, since the soil is kind of too acidic, so we are going to add it with some alkali or base in order to neutralize the acidic condition. So among A, B, C, and D, we are going to add the calcium hydroxide, which is actually a base, so that it can neutralize the acidic condition in the soil. So D will be the answer. Okay, for question 35, substance J is light and strong. It is an important material in the textile industry. The substance can be produced by adding a solution of 1,6-hexanediamine into the substance P. What is P? So P is actually this decandiol dichloride. It is actually acyl chloride. And then when it reacts with this 1,6-hexadiamine, it will become one of the material in the textile industry. Okay, for the next question. So this is the questions related to the information that shows the cell notation and voltage of two chemical cells. So this is actually related to the redox reaction of standard electropotential. So we are provided with cell 1 and cell 2, and this value is the inert cell value. Table 3 shows the standard electropotential values for some of the half cell. So we are not provided with the inert value, which is the standard electropotential value for the aluminum, and we are also not provided it with the silver. So we have another cell equation that has the equation as like this. So we are actually going to find what is the voltage of the chemical cell, right? So basically we need to find what is X and Y, and then we get what is the inert value for that. So first of all, let me introduce you how to calculate the standard electropotential, which is the voltage also. So the inert value will be inert cathode minus the inert anode. So based on this equation, actually we know that at the left hand side it will always be our anode, and then at the right hand side it will always be our cathode. This is the standard way to write for the cell notation. This whole thing is actually referred to the cell notation. So it will be equals to the inert of silver minus the inert value of the aluminum. So in an easy way, it is just Y minus X. So we are going to find Y, the value for X and Y. So we will get the answer. So how to get it? So we need to refer to this cell notation. Since we are already provided with the copper, the standard electropotential for the copper, right? Actually, we just use the formula that we get in this. We just use the formula in over here to get the inert value for this aluminum and the silver. Okay. So as always, we know that this is at the left hand side we have the anode, at the right hand side we have the cathode. So just input the value into that, then we will get the inert value. So for cell 1, okay, let's say for cell 1. So the inert value equals to the inert cathode minus the inert anode. So we have the inert value for the whole cell, which is the positive 2.00. And then the standard electropotential for copper is plus 0.34 minus the one with silver, which is our X. So our X would be plus 0.34 minus positive 2. So use your calculator to calculate it. We will get negative 1.66 watt. So we get the value for S is equals to negative 1.66 watt. Okay, so for cell 2, also copy down the same formula, which is the inert value equals to the inert cathode minus the inert anode. So in this question, we get copper as our anode and silver as our cathode. Okay, this is not this will always remain. Once you look at this cell notation, at the left hand side it will always be our anode, and then at the right hand side it will always be our cathode. So just put the value into it, and then we will get our answer. Okay, so now Y, the inert value for cathode is actually the Y, which we are going to find it. So minus the positive 0.34, and then we will get Y actually equals to positive 0.46 plus the 0.34, which is equals to 0.8 volt. So we get our Y value, which is 0.80 volt. Okay. So since we are now going to find the value, right? So we already get the Y value, which is plus 0.80 minus the X, which is negative 1.66. So we will get our answers equals to positive 2.464. So our answer would be D. Okay, this is how we solve the question. So students, you don't panic. If you really don't know how to solve the question, just follow the step-by-step guide, and then you will get it. Okay. Okay, for this question, we have the structural formula of the compound Q. So let's see what is this compound. Which organic family or homologous series is this compound Q? So we have 3 carbon atoms. So the name will be start from pro. Okay, because it contains the 3C carbon atom. And then we have the double bond group, which is the alkene. So it is actually alkene since it contains the double bond. So the name for this compound Q will be propene. So the question asks about what is the which of the following substances are formed when the compound Q reacts with steam. So steam is actually water in the gas form, or we say in the gaseous state. So water in the gaseous state we will have. So just basically we want to know when alkene react with the water, which is the steam, what will it form, right? So it will form 1 and 2, which is propan 1O and propan 2O. So the reason how it is like, okay, this double bond will actually open up. It will open up. At first it is like this, right? And then once it adds the water will actually break the double bond. Okay, it will break the double bond. So now it becomes single bond, and then this is the. So we know that for water it will have the structural formula of like this, right? 2H and 1O. So basically when it dissociates, it will form 1 positive charged hydrogen ion and 1 negatively charged hydroxide ion. So it will add like this. So how to name this? So since our hydroxide group is at the carbon number 2, right? 1, 2, and 3. So it will form propan 2O. And then since it also can this hydrogen and hydroxide ion can also switch the position, where it can become like this. The hydroxide ion can be located at the carbon number 1, and it will become now propan 1O. So let's continue with the discussion for this question. So we have an experiment that is carried out to determine the heat of combustion of the butanol. So at the left hand side we have seen, okay, this is the apparatus set up for determining the heat of combustion of the butanol. Okay, so before the combustion we have the butanol solution. We have the mass of the butanol solution, which is 258.34 grams. And after the combustion, the mass is not given and it is indicated as Y. So the provided information here is the fuel value of the butanol is 23.65 kJ per gram. And then in this experiment, the combustion of the butanol in excess oxygen will increase the 25 degrees Celsius the temperature of the 500 cm3 of the water. So what is the value of Y? Provided the specific heat capacity is 4.2 joule per gram per degree Celsius, and we have the density of the water, which is 1 gram per cm cube, and relative atomic mass of H. Okay. So basically we just want to find what is the value of Y, and then Y is the mass of the butanol after the combustion, right? So let's write the formula for the fuel value first. So the fuel value equals to the Q, which is indicated as the heat change, divided by the mass. Mass of what? So in this case, it is the mass of the system burn, which is the butanol. Okay. So actually this mass of butanol, we can know that it is the mass of the butanol burn. Okay. So this Y will be equals to the initial mass of the butanol, which is 258.34 in this case. 258.34 minus the minus the mass of the butanol burn. Okay, it is like this. So basically, let us calculate what is Q, which is the heat change first. Okay, so we know that Q equals to mc theta, and then this mass is the this m is the mass of the water that we heat up. So in this case, since we get we know that mass is equals to the volume times the density. Okay, so basically just 500 cm cube times with the 1 gram cm cube, then we will get 500 gram. Okay, so we will get 500 gram for the mass of the water. So we can put this value into the m, and then the specific heat capacity in this case is 4.2, and it increased the temperature by 25 degrees Celsius. So let's calculate it using the calculator, and then we will get 52500 joule, where if we want to convert it to kilojoule, we will get 52.5 kilojoule. Okay, since already get the heat change, which is 52.5, and then we have provided the value of the butanol, which is 23.65 kilojoule, and then we can just calculate it using the formula. So let the mass, the bottom part will be the mass of the butanol burn. So the mass will be equals to, I write it short, but you need to know it is not like that. Okay, so 52.5 kilojoule divided by 23.65 kilojoule per gram, then we will get 2.22, approximately 2.22 gram. So this is the mass of the butanol burn. So since we want to calculate for Y, and we know that Y is equals to the initial mass minus with the mass of the butanol burn that we get just now, so Y will be equals to 258.34 minus 2.22, then it will be 256.12 gram. So let's see A, B, C, and D. Okay, so we get the exact answer, which is C. So our answer would be 256.12 gram. Okay, so let's continue for the next question. So this table shows us a few series of the chemical tests. Okay, chemical tests. So we know that this is about the chemical test carried out on a salt Z, which we don't know what is salt Z, when it dissolves in water to verify the presence of the anion and cation in it. So we have altogether 3 tests. Okay, so we are going to find what are the reactants that can form the salt Z. Basically, it is just like what is the component, what makes up the salt Z. So test 1, we have the chlorine water added into it, and then we observe that the green solution turns brown. So actually this you need to refer to your textbook, or you need to memorize it. So this green solution, for the cation that present in, for the cation that shows the green color, it will be Fe2 plus. And then it turns to brown, means that it is now oxidized to Fe3 plus. So this is a oxidation, and this chlorine water is actually the reducing agent. So we know that this cation is actually the iron 2 ion, where at first it is green in color, and then it is oxidized to become Fe3 plus, which is the brown color. So, and then this second test, which is the aqueous ammonia solution, when we add it into the salt Z, the solution of the salt Z, and then it proved that the green precipitate is formed. So this is the confirmation test that this is the Fe2 plus ion for the cation. And then the last test, which is the dilute. So let's see what is the test 3. So the dilute nitric acid, which is the HNO3, is added into the solution of the salt Z. Okay, this is the solution of the salt Z. And then we add the dilute sulfuric acid dilute nitric acid into it, and then followed by the barium nitrate solution. So we observe that there is a white precipitate which is formed. So actually this is the conformation test or chemical test for the sulfate ion. So among A, B, C, and D, A is not possible because it is not green color in the solution. So the only answer we have is the iron 2 oxide and iron 2 carbonate. And since we already get the cation, which is the Fe2 plus, and the N ion is actually the sulfate ion. So the only option that we have is the D, which is the iron 2 carbonate reacts with the sulfuric acid. It will form the iron 2 sulfate. Iron 2 sulfate with the water and the carbon dioxide. So this is our answer. Okay, so let's continue with the last question. A group of students carry out an experiment to investigate the factors that affect the rate of reaction. Diagram 15 shows the sketch of graph for the reaction between the excess marble chips with the hydrochloric acid at the two different conditions. Which of the following is correct to produce the graph in the diagram 15? So let's just write the chemical equation for the reaction. For the reaction between the excess marble chips, which is actually calcium carbonate with the hydrochloric acid. So let us write the equation. So it will form the salt, which is calcium chloride, with the water and the carbon dioxide, is, if I'm not mistaken. So calcium carbonate, okay, calcium carbonate react with the hydrochloric acid, form the calcium chloride, water, and the carbon dioxide. Okay, so this volume of gas is actually the CO2. Okay, we know that it is CO2. So among the first graph, which is the green color curve and the purple color curve, so how to know whether which one is having a higher rate of reaction? So okay, we know that the answer is the 2, which is it has a higher rate of reaction. Means that the reaction completes in a shorter time. So how we know that? So you need to observe first the steepness, how steep or how is the slope of the gradient. So by comparing the gradient of the curve, we know that okay, 2 and 1. Actually 2 is more steeper. It has a steeper gradient compared to this, right? Okay, so in the set 2 reaction, it will have a greater gradient compared to the set 1. So let's see how to how to get the correct answer. So A, 40 cm of the 0.2 mole. No, it should not be 0.2, it should be 0.1, and then 2 is 0.2. It means that we have the higher concentration, so the set 2 can produce more, can have a higher rate of reaction. Okay, So for B, 40 cm3 of the 0.1 mole per dm3 hydrochloric acid with the 40 cm3 of 0.2 mole of the hydrochloric acid. Okay, C. Let's look at C. And the correct answer is C, which is 40 cm3 of 0.2 mole. So the volume is actually doesn't matter with the rate of reaction. The only thing is the concentration. And then lastly, what's wrong with it? Okay, the concentration should be terbalik. Yeah. Okay. So I think actually B is also correct. In this question, it is a bit confusing. I think B is also correct because the concentration of the set 1 and set 2 is not the same.